All right, students, this is for the Ready, Set, Go, Unit 2, Lesson 10, practice. I am just going to go over the ready and set questions in this video because at the time that I have assigned this to my students, I didn't assign the Go problems, so I don't want to make the video for those right now. I also just wanted to let you know that this is actually the second iteration of this video I'm making. I made so many mistakes in the first one, and I'm not embarrassed to make mistakes in front of you or anything, but I tell you this just to remind you that it is easy for anyone to make mistakes. I have been I've learned Algebra 1 before you were even born, and so I can still make mistakes. But the number of mistakes made the video a little bit too long. So, okay, for the ready problems, we are asked to make a graph of the function based on the following information, then write the explicit equation for the function. Now, we're never told whether we should think of these as discrete or continuous functions, but since we're writing the explicit equation, and we usually associate a recursive equation with a discrete function, we have some flexibility. It's kind of a gray area. I'm going to just go ahead and say these are all continuous. Now, we need to read these problems carefully. So in number 1, and you can draw your grid lines wherever, or your axes, but like I said, I already did this the first time, so I'm just going to put mine on here before I make the video. In number 1, at x equals 0, the y value is 5. The y value decreases by 3 units each time x increases by 1. All right, I'm going to read that again, and I'm going to write down some stuff I think is important, which is kind of both sentences. So at x equals 0, so when x is 0, if I write this as an ordered pair, that's the x value is always my first number in an ordered pair. I'm told that the y value is 5. So you know what? I'm going to just go ahead and plot that on my graph. I'm going to count by ones. So 1, 2, 3, 4, 5. And for this graph, I'm going to keep the scale the same on the x and y axis, meaning that my x-axis will also count by ones. And you can have a different scale on your x versus your y-axis, but along each axis, your scale must be consistent. All right, so I'm going to plot my point at 0, 5. And remember, that is our y-intercept. So then I'm told the y value decreases by 3 units each time x increases by 1. So as I move over from where x equals 0 on the y-axis to where x is equal to 1, my y value is going to decrease by 1, 2, 3 units. So I'm going to move over another one and decrease by 1, 2, 3 units. Now you can always, if you wish, you could make a table. Like if you are someone who likes to hold their thinking by making a table first, you can do that. It's not necessary, but it is always a possibility. All right, so when I get my points, I notice that my points form a line. This is a linear function, and if I didn't realize that from reading it, I can, see it now that connecting these points makes a straight line. Well, that's redundant because all lines are straight. If something on a graph is not straight, we call it a curve. Okay, so I'm going to put my arrows here because this line continues forever and ever in both directions. And if it didn't, we wouldn't call it a line. And in geometry, you'll learn some of the vocabulary for what we do call those things. All right, we're also asked to write the explicit equation. And we learned about point-slope form in class, but we have the y-intercept. So it might be easiest to just write this in slope-intercept form, which means we need the slope. And as we reviewed in class, you could use any pair of points on that line, but we kind of already are given the slope up here in words. Because when I think of a slope as a unit rate, I'm thinking about how do my y values increase or decrease as x increases by 1. So if I want, I could pick a ordered pair in my table, and I could say like, okay, my rise is -3 if my run is 1, or remember from class, I could use a different ordered pair. I could say my rise is -6 if my run is 2, but -6 divided by 2 is still just 3. So any way you slice it, our slope is, -3. I think I just said +3. All right, so writing my explicit equation, I could write this as y equals -3x plus 5. And that is the same as saying like 5 minus 3x. Both forms of that equation are correct. You don't need to write both as long as our coefficient of x is a -3. Remember, coefficient is like a fancy word for the number by which we multiply a variable. And you will hear that in your science classes as well. So since addition's commutative, we could also say b plus mx as long as our slope is what gets multiplied with x. All right, so in number 2, we got to be really careful here. This is the first one where I made so many mistakes. I was like, I'm just going to have to start this over. But in my defense, I'm going to tell you, I don't know that this is written very well. So at x equals 0, the y value is 16. The y value decreases by a factor of 1/4 units each time x increases by 1. And when I read that before, and I'll be honest, sometimes the hardest part of math is reading. So the first few times I read this, I wasn't sure if I was supposed to find 1/4 of 16 and subtract that, or if this meant that my next y value is 1/4 of 16. So I looked up the answer because I honestly feel like when we say decreases by, that almost implies that I would subtract that, but I think I was wrong when I was thinking about it that way. So at x equals 0, the y value is 16. So I'm going to count by 2's on my y-axis. So I'm going to say like this is 2, 4, just so that I've got it's not all jumbled together. I'm only going to label every 4, but I'm counting by 2's. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. And going the other direction, this would be like a -2, -4, just so we've got a couple negative values. All right, and then you know what? We could make our x scale different. I am going to make my x scale different just to space it out a little. I'm actually going to count every 2 spaces as one whole. So I'm going to say that's 1, 2, 3, 4, 5, 6. And going to the left, obviously where these cross, that has to be 0, 0. If I go backwards this way, that would be a -1, a -2. All right, so just to illustrate, I can have different scales on my axes as long as each axis has a consistent scale. Okay, so we said at x equals 0, the y value is 16. So again, we are given an ordered pair there, and since it is where x is 0, that is our y-intercept. X equals 0 is our y-axis. So then decreasing by a factor of 1/4, so I'm going to think, what is 1/4 of 16? 1/4 of 16 is 4. So that means that as I move over 1, and again, I'm moving over 1 unit of x, I just have a different scale, my next y value is the number 4. So then what if I move, or what if I make another move? What's 1/4 of 4? That's the same as 4 divided by 4. I'm going to get 1. So as I move over 1 more, remember my y-axis is counting by 2's. If you could totally label yours differently. That was just a personal choice I made. And then for my next point, I would get 1/4 times 1, which is just 1/4. And that's going to be really hard. Like, I can't graph that precisely, but what I could do is just get really close to my x-axis there. And remember, as I keep multiplying by 1/4, I'm never going to get to 0. I'm never going to get to 0. So what I hope you can see is that we have a curve here, and I'm going to do my best to draw it. But this is an exponential curve. It's much harder to draw than a line. And so I'm going to try not to touch the x-axis, but I'm going to get so close that it looks like I'm on the x-axis. And then to the left of the y-axis, I'm going to just do my best to sketch this. I know it's going to get steeper and steeper and steeper and steeper. All right, so this is a decreasing exponential function. And I know it's an exponential function, and I knew it before I graphed it because I had the word factor. So factor means something by which I multiply. So remember, for an exponential equation, I do not use slope-intercept form because an exponential curve does not have a slope, but it does have a y-intercept. So when I write it this way, this number is going to be my y-intercept. I like to call that b. Some textbooks call it a, and they call where I'm writing the g, they call that b. That's just fine. A lot of textbooks do that, but those letters are completely arbitrary. I like to use g for growth factor, although you could argue in this case we have decay and not growth, and that's all right. It's just what we got. Okay, so my y-intercept is 16. I am growing by a factor of 1/4, and I know I'm going to raise that to the power of x. That's what makes this exponential, is that x, or a variable, is my exponent. Similarly, you could write that, if you prefer the decimal, 0.25 in lieu of the fraction 1/4. Those are equivalent. All right, number 3, at x equals 0, the y value is 1, and the y value increases by a factor of 10. I think this is actually a typo. It says a factor of 10 times. A factor of 10 each time x increases by 1. So let me just see, did I even make room to count up to 10? So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. How about this? I'm going to label my y-axis by 2s. So I'm going to say this is 2, 4, 6, 8, 10, 12, 14, 16, 18. I was hoping to get to 20, but it doesn't actually matter. And if I needed to, I could go below that. I'm not going to, just for the sake of this video not being very long, because I'm just labeling axes. All right, and then again, kind of what I did before, I'm going to space over my x-axis differently just so I'm not writing on top of those numbers. So I'm going to go from 0, I'm going to skip over 2 spaces and call this 1. Skip over 2 spaces, call this 2, 3, 4. Going to the left of 0, -1, -2, oops, yeah, -3, -4. Okay, so at x equals 0, the y value is 1. Again, I'm given the y-intercept. So I'm going to plot the point 0, 1, and since I made the choice to count by 2 on my y-axis, I'm going to make that the spot between 0 and 2. That would be where I'm 0 on my y-axis. All right, and then we're told that the y value is going to increase, oops, that was meant to be a highlighter, increase by a factor of 10. So again, I'm looking for those words that tell me if I'm multiplying, if I'm adding, and the word factor, a factor is a number by which we multiply. So if I start at 1, my first y value is 1, and I multiply by 10, I get 10. So for my next point, as I move over 1 on my x-axis, because I'm told x is increasing by 1, so I move over 1, my y values are going to get multiplied by 10, so I will have a point up here at 1, 10. But then if I move over one more, well, 10 times 10, that's 100. There's no way this is going to fit on this graph. So what I just have to know is what this curve looks like, that it's very steep, and that it's going to get steeper very quickly, because that's what the steep part of an exponential curve does. And then on the left-hand side of the graph, I need to remember that if I go backwards, it's like I'm dividing by 10, but I'm never going to reach 0. So what we could practice is something we do often in Algebra 2, which is I could show on my graph that I have a horizontal asymptote. So if you remember the asymptote, an asymptote is like an invisible line. Sometimes we use a dashed line. We do this often in Algebra 2. It's an invisible line. Our graph is not going to cross this horizontal asymptote. So the asymptote is on the x-axis, which is at y equals 0. All right, so that is our increasing exponential curve. We are then going to write our explicit equation. So again, in that form of b times g to the power of x. Well, if b is my y-intercept, and that is a 1, my growth factor was 10, I could just write my function as 10 to the power of x. All right, lastly, number 4, at x equals 0, the y value is -8. So again, I'm given, an ordered pair. That is my y-intercept. The y value increases, so many typos, the y value increases by 2 each time x increases by 1. So if I start at -8, let's see, if I go down 1, 2, 3, 4, 5, 6, 7, oh, just enough room to count by ones without going off the space there. So that is a -8. I'm going to put the number on the left so that the negative and the tick mark don't look the same. At x equals 0, the y value is -8, and that value is going to increase by 2 each time x increases by 1. So I'll just use the same scale. So 1, 2, 3, 4, 5, 6, 7. I just label the 8s. All right, so I'm increasing by 2 as x increases by 1. Y increases by 2, x increases by 1. You only need 2 points to make a straight line, but as we are still learning about linear and exponential functions, I would make sure you get a few points, because from 2 points only, if we don't know we're working with a line, I might have an exponential curve. All right, so when I connect my points there, and if I'd made my graph differently, I would see some part of my line in quadrant 3 as well. All right, so I know my function is linear, so I'm going to use slope-intercept form of the line. So my explicit equation is y equals mx plus b. My slope is 2, because I'm going up 2 every time x increases by 1, and my y-intercept was -8. You could also write that as -8 plus 2x. All right, we're moving on to the set form, or the set part of the practice. And again, this is going to correspond with the work we did in class, the date when this was assigned. And even though we did do a lot of lesson 10 as it was written, we did practice this in class. So we said y equals mx plus b is what we call our slope-intercept form. And we call it that because we could write this equation with the slope and the y-intercept. Or I could say it reveals the slope and the y-intercept. But we have point slope form as well. So in class, we said that really in Unit 1, when we were working with explicit equations in Unit 1, we didn't know it at the time, but we were using point slope form. So m is still our slope, but the ordered pair x1, y1 represents some point on the line. And lastly, just in case you're working with any of our math tutors or you use something like on the internet to help you, just know that this could also be written this way. The only difference between these two versions of point slope form is that the constant that is currently on the right hand side, the y value, if I subtract that from both sides, it would move it over here to the left hand side where I'd see that it's being subtracted. Okay, so those are both point slope form. You could use either or, but the one that I think we have been doing kind of naturally since Unit 1 is the middle version. Okay, so we are asked to create an explicit equation in either slope-intercept or point slope form. So even though it's not specified, all of these relationships would have to be linear. We don't have a slope if we're talking about an exponential relationship. So we're asked to use the form that is most efficient. So we could almost think of that as being the fastest or the easiest way to do it. Why make it hard when we could make it easy? So the most efficient based on the given information. All right, so some of these will go pretty quickly. All right, number 5, I've got my m, my slope, I've got my b. So I'm going to say y equals negative 7x plus 4. That's all it is. I'm plugging those in, b and m. All right, number 6, I've got my slope and I've got my y-intercept. So y equals 3/8 x minus 3. 7, same deal. Y equals 16x minus 1/5. Oh, but now in number 8, which do I use? Do I want to use point slope form or slope intercept form? Well, I'll tell you it doesn't matter because the point that we're given is the y-intercept. And the way I know that is that the x value is 0. So to me, it's fastest to write 9x minus 7. But you could still do that in point slope form. It'll be correct either way. In fact, since this is a video and you don't really have to watch it, it's a choice. I'm going to show you if you did it this way, that would be in point slope form. But x minus 0 is just x. So that's why those are equivalent forms of this equation. All right, now for 9 and 10, I notice that I have a slope, but neither of the points I'm given are my y-intercept. So again, in point slope form, x1, y1 just denotes that this is a particular ordered pair on this line. And the reason we don't use x and y for that is those are variables. But if I give it that sub, like x sub 1, y sub 1, that small subscript, that indicates a particular value of x and y, not a varying value of x and y. All right, so again, going back to point slope form, I hope you wrote it down, but I will zoom out in case you didn't, although it is literally also on your piece of paper. I have y equals my slope 2/3, then x minus x sub 1. Well, be careful here because I'm subtracting a negative. Sometimes my brain wants to just write minus 6, but it is minus negative 6. And then I'm going to add my y sub 1 value to that, which is a 1. So I could also rewrite this, and I probably would. We do this a lot in geometry, actually. I would rewrite this as x plus 6, x plus positive 6. So remember, subtracting a negative is the same as adding a positive. All right, last but not least, in number 10, again, I'm given a point that's not my y-intercept. So I'm going to use point slope form because to me, that's the easiest way. You might know other ways to do it. There are other ways. So if you want to do something different, just check and make sure your answer is correct. All right, that is our equation in point slope form. All right, last part of the set section. For each table of values, write 2 different explicit equations in point slope form. And in all of my classes, I think it was on page 120 in lesson 10, yeah, I think all of them, we went over like a quick table problem on how to do this. So now I'm not given my slope, so I will have to find it, which is why we practice that skill in class, although many of you remarked you remembered that from 8th grade math, and that's wonderful because you did learn that in 8th grade math, maybe even 7th grade math. So in my table, I could remember my slope is my change in y over my change in x. We said that delta symbol represents change in mathematics. So in the first 2 rows, I can see that my x values are increasing by 1 and my y values are decreasing by 6. So my change in y is -6, my change in x is +1, my slope is -6. As we discussed thoroughly in class, you could use any pair of points in the table to find that slope, and you don't have to use consecutive rows in the table, meaning one then the one beneath it. But either way, when you simplify, you're going to get -6 as your slope. All right, so it says we have to write 2 different explicit equations, but I mean, we could really quickly write all 4. So again, in my point slope form, so I'm going to have my y, oops, that was really thicker than I thought it was going to be. I'm going to have y equals m times x minus x sub 1, that's just a particular x value, plus y sub 1, the particular y value that corresponds with that x value. All right, so I've got y equals, each time my slope is -6, so -6 x minus something plus something. Well, it doesn't matter what point we use, but let's just use this first ordered pair. If I use the first ordered pair, that would be x minus 32. And out here I'd have plus 17. But I could do it with any ordered pair. So I'm going to skip down. Let's use this ordered pair. This would be y equals -6. My slope doesn't change. It's constant rate of change. X minus 34. Out here, plus 5. All right, and then let's just do one more because I wanted to make sure we're careful when we've got a negative. So if I have y equals my slope times x minus 35, the value I'm adding is a -1. And so I could also just write that as like -6 x minus 35 minus 1. So those would both be equivalent. All right, so I hope you get the gist. How about this? I will just quickly give you one solution for each of these next ones. Looking at my table though, when I'm picking out my slope, I'm going to pick a spot if I see where x is increasing by 1 just to make the math a little easier. But I think in all the tables, x is increasing by 1. So from -52 to +51, that's a +1. From 26 to 33, that is an increase of, 7? My brain is just done for the day. All right, so that's my change in y values. 1 is my change in x values. You could use different points as long as you get a slope of 7, because 7 divided by 1 is 7. So my m is 7. All right, so I could do y equals m times x minus x sub 1. I'm going to use the -52. And since I use the -52, I have to use the +26 for my y value. And again, I would probably rewrite this as +52 so I don't have subtracting a negative. All right, you should come up with at least one more equation from that table. I'm counting that as just 1. That's not 2. That is just 1. Do another one with another point. All right, one more example. I would think by now you got it. You guys did pretty well with this in class. As x increases by 1, y is decreasing. Let's see. I'm going to work backwards. I'm going to think up from 34 to 40. That's 6. Up 3 more to get to 43. So I'm decreasing by, I already forgot what number I just said. Okay, I lied. I'm going to subtract and find the difference. I'm not this bad at doing math in my head, but it is just like almost 11 o'clock and I was teaching all day. Okay, 13 minus 4 is 9. Wow. I'm embarrassed that I couldn't do that in my head, but whatever. You could also use a calculator. All right, I'm decreasing by 9 each time. I should have picked these numbers because that stands out to me more easily as in -9. But like I said, I'm so tired. Okay, so our slope is -9 over 1 because our delta y, or at least the one that I got, was -9. The other delta x was a 1. You might use different points, but you should get a slope of -9. All right, so now again in point slope form, y equals -9. I'm just going to pick these last numbers. I don't know why. I just like them. I like 24 because it has a lot of factors. All right, -9. So I would do x minus 24, and that means I get a plus 16 here. So my last note is if you're watching this and you're like, when did we do this in Unit 1? In Unit 1, it's like a different problem. We had many tables where our n value didn't begin at 0. And so back in Unit 1, let's say I started at 5 and counted up by 2s. We learned that I could either go back and find the y-intercept, or I could write my equation starting with the 5. And if I did that, I'm adding 2, but I noticed that if I started with the 5, I was always adding 1 less 2 than my x value to get that next number. So I would have had 2 times n minus 1. And I tried to hint at this a little bit in Unit 1, but we did this frequently in our tables. And so really what we were learning back then was point slope form. We just didn't have the specific language for it yet. Oh my goodness, there's one more problem. I don't want to do it, but we need to do it because it's really important. So in number 14, for one of the tables, so you could pick any one of them from 11 through 13, show how the two equations you made in point slope form are equal. Well, I'm going to do the one in -11, or -11, number 11. I told you I'm tired. I'm going to choose that one because that's the only one for which I wrote 2 equations. You could pick something else if you want. I am going to use a calculator to do part of this though. Probably just one off screen. All right, while there are infinitely many ways that we could do this, I'm going to suggest that if I can't talk and write at the same time. I'm going to suggest what some students suggested in class today is that when I look at this, I'm just looking at my first equation, but the other one I'm going to use is this other one that was highlighted green from number 11. It might take a lot of mathematical work to manipulate one of these equations to be exactly like the other. But what we could do for each of them is I noticed that y is already isolated, but I could distribute this -6 to these two terms and then see what happens when I combine my like terms. So -6 times x is -6x. Then I'm going to think of, when I do my second distribution, I'm going to think of that as -6 times -32. And I know when I multiply two negatives, I get a positive, but off screen, I'm doing 6 times 32 in my calculator. It's not that I need one. It's that when I'm tired, my brain makes a lot more mistakes than usual. So that's why we need to prioritize rest. And I'm going to bed when I'm done with this video. All right, and then I still have the plus 17 out here. This was just my constant, my y value. So now let's just combine those like terms. 192 plus 17 is 209. So -6x plus 209. So these equations are all equivalent right here to the original. But the question is, are we able to write this one the same way? Well, let's find out. So if I distribute my -6, I get -6x. Again, when I do -6 times 34, that's going to be a positive number, but that is 204. And then I'm going to add 5 to that, And again, I get negative 6x plus 209. So what we effectively just did is we rewrote these equations in slope-intercept form. And a line only has, well, a function only has one y-intercept. So with that being the case, if I put these both in slope-intercept form, they should be the exact same, and they are. All right, Collins out.